All right, everybody, welcome to day 14 of the Advent of Cyber. Today, we're going to look at machine learning. Let's go ahead and jump over to our box and see what we've got going on. All right, today's story is the CTO has made our toy pipeline go wrong. By infecting elves at key positions in the toy making process, he has poisoned the pipeline and caused the elves to make defective toys. McSkitty has started to combat the problem by placing control elves in the pipeline. These elves take measures of toys to try and narrow down the exact location of the problematic elves in the pipeline by comparing the measurements of the defective and perfect toys. However, this is an incredibly tedious and lengthy process, so he's looking to use machine learning to optimize it. All right, so in today's objectives, we're going to learn what machine learning is, and look at the basic machine learning structures and algorithms, and then we're going to use the neural networks to predict defective toys. There's a lot of reading in this. It's a lot of understanding what machine learning is and the neural networks behind it. We're not going to go into that because that is going to take a while. I suggest everybody maybe pause this, open up, try Hack Me, and make sure that you read through and understand what machine learning is and what the neural network is. But for us, we're going to go ahead and drop down and go ahead and get started on our tasks. All right, putting it all together. Now that we've covered all the basics and that you've read everything, promise you read everything, we are ready to build our very own neural network. Start the machine at the top right, which we've already got started. It will show up in the split screen. We've got it over here. May take 2 minutes. If you find that files, you can find the files that you'll be working with on the desktop in the neural network folder. You're provided with the following files. So there are our files. Our first step is to complete the detector.py script. Let's work through the initial code that's already been added for you. So let's go ahead and open up the neural network. And we want detector.py. Let's go ahead and open this up. Let's expand this, make it bigger. All right. So we have a Python script, detector.py. Our first step is to complete this detector.py script. Let's work through the initial code. It has already been added for you in the script as shown in the snippet. Okay. So we've got everything set up here. These are our colors, so we see our nice colors. Let's work through what this code does. The first few lines in our library imports. Okay, so we're importing numpy as np, and we're importing pandas as pd. We've worked with pandas before. In the beginning we've worked with pandas before and We've worked with pandas already before. Let's go ahead and restart that. Restart, here we go. All right, let's work through the code. The first few lines are all library imports that we need for our neural network. We will make use of pandas to read our data sets and scikit-learn for building the neural network. So we've got numpy and we've got pandas that we're importing. Next, we load the data sets. In our case, there is a training and a testing data set. While we have the labels for the training data set, we don't have them for the testing data set. So while we can perform supervising learning, we will only know. So while we can perform supervised learning, we will only know our neural network's true performance once we have uploaded our predictions for review. All right, number 3, once the data has been loaded, we will need to make sure that all the inputs are numerical values. One of our data types is toys color scheme. One of our data types is the toys color scheme. In order to provide this data to our network, we need to encode the colors to numbers. And last, we will load the data Variable X is used to store our training data set together with the label stored for variable Y. Lastly, test underscore X stores the test data set while stores the test data set that will use. Lastly, test X stores the testing data set that we will use to perform the predictions on. We will start to add code required to build the train of our neural network. We will start to add the code required to build and train our neural network. We will do this in steps to perform the actions mentioned above. All right, let's create our data sets. First, we need to create data sets. In our case, we will use an 80-20 split. We will combine our validation and testing data sets as we will use the completely new data set for our testing data. To do this, we have to add the following line of code after the insert data split here. All right, so let's go ahead and copy this code. All of this is going to be very easy. It's going to be copy and pasting over and setting this up. That's why I suggested earlier we make sure that everybody goes back and reads everything. If I go read it, it's going to take 45 minutes. So let's paste this in here, and we want to paste this in the insert data split code here. Let's close this out and let's find where we can insert data split code here. Now we've got our data split code. This will split our training data set into two: X underscore train, which contains the training data, and X underscore validate, which is our validation data. Y train contains the labels of our training data, and Y validate for our labels for our validation data. Perfect. Now we need to normalize the data. Next, what we need to do is we need to normalize our data. We can do this by adding the following code after the insert normalization. So let's go ahead and copy this code. And come down here to our normalization code and insert. All right. As you can see from the lines of code, we cannot cheat by determining the normalization on either the validation or the test data sets. The normalization vector is only created from the train data, which is then applied to all three data sets. All right, next we need to train the neural network. Finally, we can train our neural network. First, what we need to do is we need to create our classifier with the following code after the insert classifier code here. So let's copy and paste this. And now let's find our classifier. So right here, we've got insert classifier training code here. So we'll put that down. You can find more information on the specific classifier here. It's a bit of an explanation of what the values are doing: solver, alpha, hidden layer sizes, and max iterations. This is the algorithm. So solver is the algorithm that's used to update these weights. Alpha is the alpha value used for the regulation. Alpha is the value used for regularization of the neural network. The hidden layer tells us the structure of the hidden layers. And then our max iteration, this sets up the cap on the number of iterations that we're going to use to train our ML. Next, we can train our classifier with the following code after the insert classifier training code here. So let's go ahead and copy that. I'm going to put this in the insert classifier training code. What? All right, let's get our classifier training code. Now let's insert the classifier training code right on this line. Should be line 69. When this step is complete, we have successfully trained our neural networks. Well, we haven't trained them, but we've got the correct code in there to train. The next step is to validate a neural network. To do this, we can ask the network to predict the values based on the validation dataset with the following code added after insert classifier validation prediction code here. So let's go ahead and copy that. Let's find that line in our scripts. And we're looking for the insert classifier validation prediction code. So we're going to drop down one. We're going to add our prediction in here. As you will see, when you execute this script, predictions are significantly faster than training the network. This is why the neural networks can actually be used in real life. This is why neural networks can actually be used in real life applications. As the prediction rate is increasingly fast, as the prediction rate is incredibly fast once the network has been trained. We can determine the accuracy of our classifier by comparing the two arrays with the following code. This function tests how well your prediction and validation set. All right, so this code is already in here. This function tests how well the neural network prediction performs. So we've got that code in here already. Oh, wait. We've got that code already in here. As you will see, when we run this code, the neural network is pretty accurate. All right, let's go to the next. Saving the poison toy pipeline. Finally, at the last step, we can now ask our neural network to make a prediction on the testing data that was not labeled by the elves with the following code after the insert classifier testing prediction here. So let's go ahead and copy here and find that line. We'll add that to line 94. This is it. We are finally ready to train and run our network from the terminal to run the application. That's it. Now we're finally ready to train and run our network. From the terminal, let's run this application. So let's go ahead and let's save this and close it. And let's go ahead and open up a terminal and run. So let's make sure we've got everything on here. We need to be in a desktop. We're in the correct working directory. Let's go ahead and clear. So now we need to run our detector. So we need to run Python. Now that we're clear and we're in our directory, let's go ahead and run Python. Python 3. All right, now we've got a clear terminal here. Let's go ahead and run Python and 3, and then we want to run detector.py, and let's hit it. We'll go ahead and make this larger, that way we can see it as it runs. All right, so it looks like we finished, and it looks like training has complete, validating the neural network. Total correct 18,334. Total incorrect Total incorrect is 1,666. Network accuracy 91%. Now we will predict the testing data set for which don't have correct answers. They save that prediction to a file. Predictions are saved, and the file has now been uploaded to verify your neural network. Perfect. These predictions will be saved to a file. Upload your predictions here. So we'll see. All right. These predictions will be saved to a file. Upload your predictions here at this website to see how well your neural network has performed. If your accuracy is above 90%, you will be awarded with a flag. And McSkitty's toy pipeline will be saved. So let's go ahead and open up Firefox and see if our predictions are correct. So I'm going to browse our file. And we've got our predictions.txt. Let's go ahead and open, upload, 91.47, and there is our flag. Woohoo! All right, neural network accuracy. If your neural network is not able to reach 90% accuracy, run the script again and retrain your network and submit the new predictions. Usually within 2 or 3 rounds, you should have an accuracy of above 90%. We hit it on the first try. Lucky us. Let's go ahead and scroll down, see what else we have in here. Cybersecurity applications for machine learning. Machine learning and or AI, as it is often called. All right, cybersecurity applications for machine learning. Machine learning, or AI as it is often called out there in the real world, has real life applications for cybersecurity, and here are just a few of them. As shown in today's example, machine learning structures are incredible at finding complex patterns in data and performing predictions on the large data sets with incredible accuracy. While humans can often do the same, the sheer amount of data and predictions required can be overwhelming. Furthermore, the intricate connections between different inputs cannot be determined by a human, whereas machine learning structures can learn these decision boundaries in hyperspace. All right, machine learning structures are incredibly good at anomaly detection, and machine learning structures have the ability to learn complex patterns. They can be used for authentication applications such as biometric applications or biometric authentication. Also, machine learning structures have the ability to learn complex patterns. They can be used for authentication applications such as biometric authentications. Machine learning structures can be used to predict whether a person's fingerprint or iris matches a template that has been stored to provide access to a building. And last but definitely not least, it's what everybody talks about, the cautions of machine learning. All right, last but not least, are cybersecurity cautions for machine learning. While there are many benefits to machine learning and cybersecurity, caution should be observed for the following reasons. Machine learning, just like humans, is inherently imperfect. That's a very good reason why the answer provided by the neural network is called a prediction. It's just that, it's a prediction. As you saw in today's example, while we can get incredibly accurate predictions from our network, it's impossible for it to be 100% correct. For this reason, we should remember that AI isn't just the silver bullet for all problems. It will never be perfect, but it should be used in conjunction with humans so they can play to each other's strengths. Last, the same power that allows machine learning to be used for defense means can also be used for offensive means. As we will show you in tomorrow's task, ML structures and AI can also be used to attack systems. We should therefore always consider this a potential threat to the systems that we create. All right, let's go ahead and run through these questions and see if we can get them answered. Now remember, a lot of these are going to be rolling back into what we should have read before. So if you didn't read, make sure you go back through and read it so you can answer these questions. What is the other term given for artificial intelligence or a subset of AI meant for teaching computers? That was machine learning. So ta-da! What machine learning structure aims to mimic the process of the natural selection of evolution? That was genetic. Whoop, where are we at? Where's my there it is. That is the genetic algorithm. Hope I spelled that right. There we go. What is the name of the learning style that makes use of the labeled data that's trained in the machine learning structure? That's going to be supervised learning. We had two different types of learning. We had a couple of different types of learning, so this one's supervised. All right, our next question. What is the name of the layer between the input layer and the output layer of our neural network? Back in the reading, we had the input layer, we had a hidden layer, and then we had the output layer. So our answer here is going to be hidden layer. What is the name of the process used to provide feedback to the neural network on how close its prediction was? So we go back to our reading, and that was called backpropagation. Let me scroll up here. We'll copy and paste backpropagation. Scroll down. Submit. And then, what is the value of the flag you received after achieving more than 90% woohoo, of accuracy of your submitted predictions? That's our flag. We'll copy it and paste it. And we are done for today. All right. If you enjoyed this room, we invite you to join our Discord server for the ongoing support, exclusive tips, and the community of peers to enhance your advent of cyber experience. Go jump on the Try Hack Me Discord, get some questions answered, ask around, join the community, have fun. I will see everybody tomorrow. All right. Try Hack Me says at the last one, if you enjoyed this room, go join their Discord. If you can, go jump on their Discord. Great people there. Answer your questions, help you out, get some exclusive tips and so forth. That's it for day 14 of the Advent of Cyber. It looks like tomorrow we're going to continue on with our machine learning, but we're going to be attacking. We're going to be the offense. So I'll look to see everybody tomorrow, and I'll see you. So I look to see to. So hopefully I will see everybody tomorrow for the second round of machine learning on day 15. Till then.